All right, let's look at this example 7 in section 12.2. We are going to change these angles so that it's easier for us to calculate. Otherwise, we need a calculator. Now, for this problem too, we have different methods. The one we are going to use is from the textbook. But you will see our explanation is going to be a little bit easier because we are using these very special angles over here. All right. For these problems, the most important thing we realize is that when we add two forces, we are using vector addition. So really, we are trying to find vectors for these forces to represent these forces. Okay. So the key word over here is that we need to have balance of forces. Okay. Now, if you look at this one over here, because we want to write down the components for vectors, it's a good idea to draw a good Cartesian or XY coordinate system. And if you do this, then we have very good representation for these forces. The gravitational force over here is 100 pounds. Okay. So what we want to have is that these two forces, T1, this force, plus this T2, this force, is going to be 100, but it's pointing upward, so it's going to be 0 and 100. So this is what we want to have. Okay. Now T1, T2, they have two components. T1, you can see, if we know the hypotenuse, then this one over here, this is also 60 degree. So we will see this is 30 degree, but doesn't look like that way, but that's okay. So if we want to find this, then this is cosine. So T1, if you look at the component over here, it's going to be T1 length and then cosine 60 degree. Okay. And then it's actually this is always going to be true. It's vertical direction component is sine 60 degree. Okay, and T2 we have two components, and that's exactly the same. T2 is going to be T2's magnitude, but this time we have cosine 30 degree. You see over here is 30 degree, right? It's parallel 30 degree. And second one is T2 and sine 30 degree. Okay. And so what we have over here is really T1, this vector is equal to T1, and then we have cosine 60 degree, we know it's 1/2, right? And second one over here, we have T1, sine 60 degree, we have √3/2. And T2 over here is going to be T2 cosine 30 degree is √3/2, and T2, and here we're going to have 1/2. Now, to have the balance, we must have the following thing, and that in the horizontal direction, they're going to be the same. So T1 times 1/2 must be equal to T2 times √3/2. So if you think about it, multiply to both sides, that means T1 is going to be T2 times √3. And in the vertical direction, we must have 100. So we have T1 √3 plus 2 plus T2 1/2 must be 100. So what we have is that T1 √3 plus T2 is equal to 200, right? So now using these two equations, 1 and 2, and then we can find that, because if we substitute T1 inside, then we will see 3T2 plus T2, add them up over here, Yeah, that's right. And substitute inside. And that's going to be 200. So 42 is going to be 200. T2 is going to be 200 divided by 4. And it's exactly 50. That's 50 pounds in the units. Now, if T2 is 50 pounds, then T1 is going to be root 3 times T2, and that's going to be root 3 times 50, or just reverse it as 50 root 3. And once we have this, the final answer, if we use the ij form, then we have T1, this vector, is equal to 1/2 of T1. That's going to be 25 root 3. And the second one over here, T1 times root 3 over 2. So T1 is this times root 3, and that's going to be is that 75. If you look at it over here, it's 25 times 3, and that's going to be 75. And how about T2? T2 will be just the opposite. We know that T2 is going to be 50, so in fact, this is going to be the same because we know. But one is positive, one is negative. So this one is negative over here. And this is positive, 25 and 3. And then we have 75 over here. Now we're going to have 25 over here because it's T2 divided by 1/2. So that's the answer we have for this problem.